recording. There we go. So, which means I have to slowly scroll through this again for the people who are watching the recording. Zoom this out a little bit. So here we go. This is what I assigned. Comments, questions, concerns on any of it. Remember, this was no calculator. Oh, and then there's that guy there. I had a question yesterday emailed to me. Let's see if I can pull that up. Where is that question? There it is. Found it. Sorry. The question was the adding integers part in our notes. It says to follow the direction of the second number, but when we start with a negative number and subtract it from a negative number, why do we move towards the positive number? So I gave you a set of instructions for adding integers, and I said when you're moving, if like in your head, like if you're not working with a calculator and you want to make sure you're thinking about it properly, you're moving in the direction of the second number. So I said when you're adding, you start with a positive value, you're adding to it a negative value, you're becoming less positive or more negative, so that you can think about that as far as making sure that you're at least moving in the right direction when you're doing these things mentally. The question then jumps in and says, but what about subtraction? Well, subtraction, I didn't say that. Subtraction is an entirely different beast. Subtraction, we're taking things away. So you can't apply something that I said for one concept to another concept, which is the first part of the problem. And they gave an example, negative 12 minus negative 5 equals negative 7. Why is the answer going towards 0 instead of becoming more negative? And so I'll write out, is that question on here? No, I'll write out the question that they sent me in an email, this person, who shall remain nameless. So here we are, negative 12 minus negative 5. So there's a few ways that you can think about this. If you're doing mental math, if mental math is still is a struggle, you can think about it a couple ways. So the operation of subtraction is taking away. You are removing things. Hey now, be nice. Flipping each other off in class is not okay. Also, no trash talking your classmates behind their back. Okay, enough, ladies. Subtraction, you're literally taking something away. So if you're taking away a negative, does it make sense for that thing to become more negative or less negative? You're taking away negative things. You can think about it over the course, think about it in terms of dollars, like money. If you owe me money, that's like you having negative money. You owe me $12, and I take away $5 from what you owe me. How much do you owe me now? You owed me 12, I took away 5. You owe me 7. So if you think about negatives in terms of like what you owe or what you are being owed, that would be a positive. It makes a lot of sense, I think, right? Like taking away a negative gets you a more positive value. So then there's another one here. Also, when we subtract a positive from a negative, why does it get smaller? Negative 2 minus 5 equals negative 7. So again, taking away taking away a positive value makes things smaller. And again, you can think of it in terms of, do I want to think of it in terms of money again? I don't know if money is a good way to think about this one, but the idea of negative 2 taking away 5 more. So you already owe $2, and now you owe you've taken now an additional 5 from me. Now you owe 7. If you want to think about it in terms of that, I don't know if this is helping the person who asked the question. I'm hoping that it is. It's all about what that operator means. Subtraction is taking something away, and then if you're taking away a positive, that makes things more negative. If you're taking away negative things, it makes things more positive. Does that help at all? Okay. So that was kind of the question I was asked yesterday, and then I gave you a bunch of these things. So there's no questions about the rounding, no questions about any of these things. The mental math was easy for you. Everywhere I scribbled is where I made a mistake.
I got like 12 and 14 wrong, and I'm not sure
You got 12 and 14 wrong, or you got it different than I got? Because we don't know if you're wrong
No,
yet.
I think I'm wrong.
You think you're wrong, okay?
Because I don't know what I was, like, I don't know, none of the calculations I did were wrong.
Or overly difficult, perhaps.
Or overly difficult, because they're little sections. But
Yep.
I don't know, like, the order that I did it.
Okay, so talk to me about 12. What did you do?
Can we go through, I can't remember what I did, because I just wrote down random numbers here and there.
So it's really important for you guys to show your work more than it is for me to show my work. I will show my work on any question that you guys bring to me, but otherwise I'm just going to give you the answers for them. You need to show me this is one of those do as I say, not as I do kind of scenarios, which students love. I say that tongue firmly planted in my cheek, because I know you all hate it when people say that. Do as I say, not as I do. You need to show your work. When I do examples, I'll show you. When I'm giving you answers, I won't unless we have this situation. So let's do it. For number 12, the very first thing that we're going to do is what? We're going through bed math, so we're going to look at the brackets. There's math going on in the brackets. So I've got 5 times 2 minus 9. In there, what do I do first? We do the 5 times 2. 5 times 2 is 10. Now I'm going to take the 10 and I'm going to minus 9. It's 1. So that's why I've got that 1 written above this whole set of brackets. Because this whole thing simplifies to 1. Okay? What happens next? 13 minus 1, which is? Okay, so let's get rid of that. Let's make that 12. What happens next? The negative 3 times 4. Because when you've got something in the denominator of a fraction, we treat it like it has brackets written around it. So I've got my negative 3 times 4, which is negative 12, plus 5. And now what's my next step? Do the division, okay? What's 12 divided by negative 12? Negative 1 plus 5 is? So that's how we got what we got.
Yeah.
So where did...
So I did all of those steps.
Did you drop the negative when you did the division here? What was the answer you got?
I got 17 somehow.
Whoa.
And I was like, this is not right.
Oh, you didn't do the subtraction. You just did 12 plus 5.
Oh. Because I did something weird there.
You simplified it weirdly in your head very quickly. Yeah.
Okay.
No, that's a mistake. So you have the division here relieves you with 1, not 12. Nika, I see that hand behind you.
Yeah.
Behind Danny, rather.
How do you do number 6 with the adding fractions? I don't remember what I got for that. But it was not.
Okay, so I didn't actually do this by adding fractions. I did the bed mass first. Fractions are just what operation? Fractions are just division. So 12 divided by 4 is? And 15 divided by 3 is? So now I've done the division. Now all I have left is the addition. 3 plus 5 is 8. The addition, if you're trying to add them like fractions, which we're going to do today, you got to be real careful, because something like 15 times 4 is going to mess you up, and you got to make sure you simplify it properly and all that stuff. If you can reduce your fractions so that they're no longer fractions, that's always better first. Danny, did you also want me to do, you said 14?
Sure.
Was that the one that you said was different?
No, I got negative 12. I literally don't know. I was like, this is wrong, but I'm just going to see what it is wrong. Yeah.
Okay, well, let's walk it through and see what happened. I've got 2 fractions here. I've got lots of mathematical operations going on inside all sorts of different places. What do I do first? The brackets. And you can do the brackets at the same time. Like, you don't have to do them and then rewrite like one and then rewrite everything. We can do them together. So I've got this set of brackets here. I've got this set of brackets here. And I've got this set of brackets here. 2 plus 3 plus 5, it's all addition. Let's just do it. 2 plus 3 plus 5 is 10. 2 minus 5 is negative 3, which I've got written there. And 5 times 2 minus 3. What happens first in there? I'll zoom this in here. 5 times 2, which is minus 3, which is, so that's how I got the 7. What do I do next? Okay, so I can start dealing with the numerators and the denominators kind of as individual chunks. So I've got negative 4 times 10. That's where I got this negative 40 from. multiplication and division can be done together because they are inverse operations for each other, and you do them left to right. So 4 times 4 is, divided by 2 is, cool. So now this fraction becomes negative 40 over 8. This one, I've got negative 3 and a 7 here. Negative 3 times 7 is negative 21. And I'm multiplying them why? Yeah, because there's brackets there, and if there's no operator between a set of brackets, it's multiplication. Okay. So then I got 3 times 6 minus 11. What happens first there? Which is minus 11, which is? So now I've got this mess. What do I do next? This actually looks a lot like Nika's question out of number 6. I've got 2 fractions, and I'm subtracting them. I could, as Nika suggested earlier, treat these like adding fractions, but that's going to get gross really fast because the lowest common multiple of 8 and 7 is what? 56, which means I'm multiplying 21 by 8 and 40 by 7, which is doable, but not something I necessarily want to do if I can avoid it. What is nice about these fractions? They're all simplifiable. Really, like you can do the division really easily. Negative 40 divided by 8 is negative 5. And negative 21 divided by 7 is negative 3. And I'm still subtracting these values. Negative 5 minus negative 3 is going to do this. Becomes negative 5 plus 3, which is negative 2. How you got...
Maybe I add an extra 1 or something.
12.
All of the steps.
I don't know.
Every single one of them.
I don't know. Unless I saw your work, I don't know if I can help you help you identify the mistake.
Maybe I added a 1. I wasn't thinking. Because I did all of that.
Just spontaneously adding ones and minus. Like,
Sometimes I do that if I'm thinking about something else. Like I see one.
yeah, no, I gotcha. It's just something I see fairly common. Usually people don't add things; they just drop things, but it happens. I get it. And I mean, sometimes it's even like I mean, you can see everywhere I scribbled something out. That wasn't a mistake in me writing it down. That was me recognizing that my mental math was not up to par. I was doing this while you guys were here sitting in class, and so I was having trouble focusing on things, and it happens. And I've been doing this longer than you've been alive, and so if I can't do it sometimes, then it's totally understandable why mental math is not always right there for you. So here's the rounding. Any issues with the rounding? Comments, questions, concerns with the rounding? Okay, hearing not a lot. I'm going to get real frustrated if all of a sudden your guys' version of rounding is just dropping off the numbers after the place be round, because y'all say you're good, so you say you're good. Okay. There's no issues here. I'm going to get real picky. Yes? This one? Oh, the 10th. This one? This one. That's the one we did together. Okay, I'll do it again. So the tenths is the first decimal place after, or the first place after the decimal. So then you look to the one to the right. That number is bigger than 5. So that's going to make my 9 a 10, which makes that a 0, and then the 1 gets carried up to the next spot. Which is why it becomes, that 7 becomes an 8. But I need to have the 0.0 because I'm rounding to a 10th. I need to have a 10th spot. So even though it's 0, I still include it. Does all of that answer whatever your question was? Okay. It's the same thing that happened down here in this very last one with number, with 99,912.9898. This, rounding it to the thousandths, I look one to the right. That's bigger than 5, so that 9 becomes a 10, which makes that 8 a 9, so that 9 becomes a 0, and I'm left with 0.990. I need to have something in that thousandths spot, otherwise we haven't rounded to it. And you might say, well, why is this even remotely important? When you where you start to apply this stuff is when you start doing like labs in chemistry and in physics, is really where this is going to get super neurotic. because you're going to introduce to something called sig figs, either in Chem 11 or Physics 11, or both. And you're going to get introduced to the concept called error. Like when you take a measurement, the measurements you take aren't perfect. I don't care how good you think you are. I guarantee that you're not perfect. Why? Well, because someone, first of all, even assuming that you're perfect with the tool that you've been given, someone somewhere made that tool. And are they perfect? Well, they might be pretty close, but are they perfect? Well, we can't assume that they are. So I can't assume that you're perfect. I can't assume that the tool that was made for me to use is perfect. And I can't assume that the situation that you're measuring in is also perfect. And so we take all of those things into account and we introduce something called error. So my measurement gets made. Maybe I'm measuring my height. I am 5'10" and a half-ish, depending on what time of day you measure me. But that 0.5 might not be 0.5, it might be 0.4, it might be 0.6. It depends on the tool that I'm using to measure it. So we say that I'm 5'10" and a half and we call it good. I'd love to say that I'm 5'11", but that's more for my ego than anything. But the idea that last digit could be 1 up or 1 down is that idea of error. And when you're doing labs and you're actually measuring things in chemistry and you're mixing chemicals or whatnot, it is actually really important for you to quote that error. And so that's where we're going to get, yes, I get it, it's grade 9, that's still a couple years away, but we're going to get really neurotic about having proper rounding and proper decimal places later on. And so if you're good with it now, and the idea is that you're good now, and you remain good so that we don't have to reteach rounding to a bunch of 17 and 18-year-olds in my Physics 11 and 12 class, because that gets irritating. All of that to say, rounding's important. Comments, questions, concerns on any part of that? Okay, cool. So I gave you some extra practice here. If you want to do it, great. If not, whatever. I've got an answer key for this. If you did choose to do this, hands up if you'd like to see the answer key for this. There's a few of you. Okay, cool. Let's take a look at that really fast. If you did it because, for whatever reason you thought it was going to be awesome to do, here they are. I'll just slowly scroll this up. This is now also, I'm recording all of this, so this is now part of the video. If you do it later as extra practice, as maybe review for your first test, for example, that's coming up soon, you can go back and you can check the answers in the video because I'm filming it today, so that's cool. Here's the bottom. Sometimes I stop and say things to give people who are reading the screen time to catch up, and so there's not that awkward dead silence. Can anyone else hear the music coming through the wall? It's really pretty today. Yesterday it was not so much. Today it's really pretty. Comments, questions, concerns on any of these? This is just adding integers, subtracting, multiplying, dividing, in your head, mental math. Okay, we're still checking. Check faster.
Okay.
So people are still checking. When you're done with this page, make a big deal of flipping the page so I can actually tell who's looking. There we go, thank you. Because when you guys subtly flip the page, I don't actually know if anyone's done. But if you make a big deal about it, then I know. Here we go, here's the next chunk. This is I expect you guys to be able to add and subtract simple things. It's for the bed mass where I expect to start tripping you up. I like question number 28 because you literally did all that work for nothing. It's good. Because the answer is 0. I once gave my students a question that took them I wrote it on the whiteboard and it took me from one end of the whiteboard to the other end of a double whiteboard. It was awesome. And the answer was 0 and they were pissed. Because they literally did all that. They probably took them about half an hour to do. They did all that work for nothing. Great. And then the rounding here at the bottom, I rewrote this one because it was messy. Oh, also, going back to the get to know you thing, things that I do that might make things in class more difficult for you. Sometimes if I'm writing fast, my 4s look like 9s. If that becomes an issue, please, if you're confused, please say something. My 4s definitely sometimes look like 9s. My 9s look more like 9s than my 4s do, but they both still do. Okay, flip page, here we go. We're going to go moving on, looking at adding and subtracting fractions. You guys were good with this. I just want to make sure that we can do this all in our head, nice and easy. Because I know math was a long time ago for some of you. Grade 8 feels like an eternity ago. Adding fractions, we want the common denominator. Bottoms must be the same. An easy way to do this, we said yesterday, was to find the lowest common multiple. Does it have to be a lowest common multiple? Ladies and gentlemen, do we have to have the lowest common multiple? No, I do not have to have the lowest common multiple. But if I don't have the lowest common multiple, what will I probably have to do? Simplify or reduce. Those words can be used interchangeably here, okay? So if you can't find the lowest common multiple, whatever, find a multiple, make the denominators the same, and then at the end of it all, you must write the fraction in lowest terms, which means you simplify or reduce. Caroline, do you have a Learn34 account already? Okay, then everything we've done up to this point, which you probably know how to do, but if you want to go back and take a look at the videos just to make sure you're all good, are in my Google Classroom. I'll show you before you leave today at the end of the day, just so you know where to go look. Okay, if the fraction's negative, often when we have negative fractions, they get written like this, where the negative just hangs out in front of that, the fraction sign, or that bar in the middle of the quotient. What do we do with that? What have you done with that in the past? No, see, yeah, classic. We ignore it. You don't ignore it. Ignoring is bad. We want to embrace our problems. We want to face them head on. We don't want to ignore our problems. This is a problem. What do we do with it? Okay, cool. I will tell you what you do. It doesn't matter what you do, but you must do one of two things. Typically, because I won't say that always this is the best thing to do, but usually the best thing to do is to take this negative and actually make it commit to a piece of the fraction. And what I mean by that is this. You take the negative and you just make the numerator negative. It amounts to this. That's an arrow for those of you who are looking closely. It amounts to the same thing as if, like, so what I mean by that is this. I'm writing this now as negative 2 over 5 minus a quarter. It's the same thing. It doesn't matter if the negative is in the numerator or it's in the denominator, but it has to be in one of those two spots. For adding and subtracting fractions, when this is the concept, it is always better to put the negative in the numerator. There will be times in the future where it is better to put it in the denominator. Excuse me, it's better to put it in the denominator. When we get there, I will tell you about that. But when we're dealing with like exponent laws, there will be times when simplifying exponents, which is something you should have done a little bit of in grade 8. We remember simplifying exponents? Like you remember 10% of it? Or was that your example of?
No, we did like 10% of it.
A little bit of it. A little bit. Okay. So sometimes when you're doing that, it's nice to not put it in the numerator, to put it in the denominator instead, but we'll get there. For now, always put it in the negative into the numerator. If the fraction is negative, the word I'm going to use here is absorb the negative sign into the numerator. Oh, and I'm going off the page. And then we just add it and subtract it like we do everything else. If I have I've got negative 2/5 minus a quarter, I want to find a common denominator. What is a common denominator of 5 and 4? Or sorry, the lowest common multiple of 5 and 4. Sorry? 20. Not what I heard. I heard 1 for some reason. for 20. If I want to make these, so I want to make these things both fractions out of 20. What do I have to do to the top and bottom of my first fraction? Multiply top and bottom by 4. And my second fraction, I multiply top and bottom by 5. Okay, cool. So that's going to become negative 8 over 20 minus 5 over 20. And then the last thing I do here is what? I subtract the tops, which y'all could do earlier. It just wasn't in the form of a fraction. So now I'm going to have my denominator. It's still going to be 20 on the bottom. And negative 8 minus 5, I'm at negative 8. I'm taking away 5, so I'm going more negative. What's this value? It's negative 13. Is that thing reducible? No, we're good. Sometimes you're going to be given a mixed number. There are ways to deal with mixed numbers. My pro tip for dealing with mixed numbers is to rewrite them as improper fractions. What is an improper fraction? The numerator is larger than the denominator. Good. That is an improper fraction. How do we convert from a mixed number? So a mixed number is a whole number and a fraction. How do I convert from a mixed number to an improper fraction? Yes, Harwin. You're close, but you're exactly backwards. It's the denominator times the numerator. Sorry, it's the denominator times the whole number, and you add it to the numerator. So you multiply here, and then you add going this way. Which looks like the same thing now that I've written it like that, because my x's and pluses look very similar. So anyway, what I'm going to get here now is that 2 times 3 is, plus 1 is 7. So that becomes 7 over 2. 3 times 4 is, plus 2 is 14. This becomes 14 thirds. And now what do I do? Common denominator is 6. So I multiply top and bottom on the left fraction by what? Multiply top and bottom by 3. Cool. I multiply the top and bottom of the right one by, so that's going to give me 21 over 6 plus 28 over 6, which someone has already said is 49 over 6. And I don't care if your final answer is mixed or improper. The only thing I care about 100% of the time is that your fractions are in lowest terms. That is the hill I will die on. I don't care if it's mixed or improper. But for the sake of interest, if I wanted, unless I specify, if I want this in mixed number form, what do I have to do? See how many times 6 goes into 49? So there's some mental math here. 6 goes into 49 how many times? And what do I have? And 6 times 8 is 48. So I've got 1 left over. So that becomes my numerator. Oh, look, it looks an awful lot like what we had from long division on day 1. 8 1/6. So a mixed number is just the division and the remainder divided by our divisor. It's cool. I like it. Okay. How do we feel about adding and subtracting fractions? Is it coming back? Some of you are nodding. Some of you are just staring. I'm hoping the staring is internal nodding. If it's not, I'm happy to help. Multiplying fractions. We like to multiply fractions because multiplying fractions is easier. How do we multiply fractions? Multiply the new. We do not cross multiply. No. Someone did, and I don't care who it was. I don't know, don't out each other. That's fine. I don't care who it was. But that is a bad idea. And I'll explain why. And it's important that, and I do want to kind of make a bigger deal about that now, because my physics, again, it always comes back to my physics 11s, and I think I heard someone mutter, why the physics 11s? Because that's what I'm teaching right now, and that's the problem that I'm having. They still think, oh, just cross multiply. Like, no, it's not, no, don't cross multiply. You multiply the numerators, then the denominators, then simplify if possible. I agree with whoever said that. Okay, you guys are never as quiet as you think you are, first of all. Second of all, I have phenomenal hearing. But be aware, you guys are never as quiet as you think you are. I'm going to put a star next to this because this is only usually true. Sometimes it's better to do some fun simplification before you do the multiplication, because then it can make your life a little bit easier. I'll show you what I mean by that. So we're going to do this question two different ways. Number one, we're going to follow the instructions that I gave you. Multiply the numerators, multiply the denominators, simplify if possible. So what's 1/4 times 6/7? 6/28. I just heard that. Yes? Is that what I heard? Someone said it? 1 times 6 is 6. 4 times 7 is 28. Is that thing in the lowest terms? What do I got to do to it? I can divide each by 2, you say, okay? Divide top by 2, divide bottom by 2. So leaves me with what? 3/14. That is one option. The other option, there's a technique here that sometimes it's easier to do. No. Sorry. Is that Harwin? Not cross multiplying.
I said simplify.
Okay, it was Harwin.
I wasn't.
You were right. Cross simplify, which is a technique you've probably seen before. And it only works when all you're doing is multiplying and dividing. And it works because multiplying and dividing can be done in any order, because multiplying and dividing are inverse operations of each other. So what that means is this 1/4 times 6/7, I can prove to you why it works here in a second, but for the sake of this, I'm just going to do it. What we're allowed to do, then this isn't cross multiplication, it's cross simplification. My numerator is these things, my denominator is these things. Because I'm multiplying these fractions, what I'm allowed to do is I can simplify any numerator with any denominator because I'm multiplying these fractions together. So what I'm allowed to do is I'm actually allowed to simplify these two just to start. What can I divide 4 and 6 by? I can divide both by 2. So that's going to give me 1/2 times 3/7. If I do that math, what do I get? 3/14. Oh, look. And it had better had been the same. It's the same. Okay? So you can do your reductions early to save yourself some brain power. Now, in a question like this, obviously that doesn't necessarily save us a lot of time. But what if I gave you a question that looks like this? Here's another example I want you to write down. 28/183 times 61/14. Okay, so we're going to make our lives a little easier now. First, we're going to start off by saying, I was Harwin again, said that 28 and 14 are simplifiable. And because all I'm doing is multiplying fractions here, I can cross simplify. 28 and 14 can be both divided by 2. What else can it be divided by? 7. It can also be divided by 14. So let's go big or go home, right? Let's go straight to the big one. 28 divided by 14 is Excuse me? 28 divided by 14 is 2. Thank you. 14 divided by 14 is 1. Can I make any other simplifications? $61 times 3 is what? 183. Interesting. It's like I picked those numbers on purpose. So I can divide this by 61, and this by 61, because 61 is prime. 61 divided by 61 is 1. 183 divided by 61 is 3. And my answer is 2/3, because 2/3 times 1 is 1. And here, if I told you to do that in your head, you probably would have gotten out a pen and paper and done longhand 28 times 61, and we'd still be sitting here. Okay? There are techniques that will shortcut the situation. Usually, multiply the numerators, then the denominators, and simplify if possible. But there is a technique, and there's a time and a place for it when the numbers are gross to simplify first. Sometimes, cross simplify first. Do I need to prove to any of you why this works, or do we understand why it works? Does anyone want to see the proof of why this works? Okay, some of you want to see the proof. Let's do it. Okay, to prove it to you, I'm going to go back to the easier one. Okay, so here's my proof. I'm going to do the proof in black. And we're going to go back to the easy one. The easy one was 1/4 times 6 over 7. Okay, so to prove it to you, I'm going to talk through what we did. I'm going to write down what we did in such a way that it's overly obvious what's happening here. I'm going to insert more steps than you would if you did this problem to prove to you why this works. Okay, here we go. So we said multiply the numerators, multiply the denominators, and that becomes your new fraction, yes? So let's do it. Except I'm just going to write it. 1 times 6 over 4 times 7. We're cool with what I've just done, yes? Okay. Multiplication is commutative, which is a fun word that means you can do it in any order, which is really important. 1 times 6 and 6 times 1 are the same number. That's not always true for all operations, but multiplication works that way. It doesn't matter which way you go, you get the same result. You might think that that's obvious, and why would that ever not be true? Trust me, it's not always true. One day, you will find things that are not true. So I can rewrite this as 6 times 1 over 4 times 7. Okay? Did someone just say no? No? Okay. Pretty sure you did. That's okay. Okay, so then I can, but now I just did 1 times 4 times 6 over 7, so then and then I flipped them. But so I can undo now this if I wanted to. I could separate these things back up into 6/4 times 1/7. Yeah, I haven't done anything bad here. We're all still good? And, well, we can reduce fractions. We're allowed to do that, right? Because it's just a fraction. So 6 and 4 are both divisible by 2. So 6 divided by 2 is 3. 4 divided by 2 is 2. Times 1 over 7 gives me 3/14, which is exactly what we started with. So all of this to say, because multiplication is commutative, meaning I can swap the order of it, I'm allowed to do these kinds of simplifications here in the middle. And again, it's not, you look at this and say, well, this is a stupid easy question, why would I ever bother doing that? Because they won't always be. And to have techniques like this easily accessible to you makes you better mathematicians in the long run. The faster you can pull out these tricks, the better you'll be. And there's other tricks I'm going to show you. Things like adding 0 and multiplying by 1, except it doesn't look like you're adding 0 and multiplying by 1, but you are. And there's different 1s and 0s to multiply. It's going to be great. Comments, questions? Is this sufficiently, have I convinced you? Okay, fantastic. Flip the page. Okay. Do I need to do another example of improper, or are we good? We're good, fantastic, I love it. I make a note here again. I said it before, I'll say it again. Your final answer may be written as mixed or left as improper. Unless I specify, I don't care, but it must be in lowest terms. Let's review dividing fractions, shall we? When dividing fractions, the first thing you want to do is you want to rewrite any mixed fractions as what kind of fraction? Improper. And what do? You make it multiplication. Well, how does that work? How can we do that? Oh yes, that one word. That one word is really important right now. No, it does not start with an I. Yeah, your middle school teacher abused that word. Yes, the word you're looking for is invert, I think. That's the only one that starts with an I that even remotely makes sense. The actual word starts with an R. Recip. You're right. You get the reciprocal by reciprocating. Means you flip it. You flip what you're dividing by, which is the second fraction, over. This new fraction is the reciprocal of the original second fraction. So dividing by a fraction is the same thing as multiplying by its reciprocal. So we can do one of these relatively easily here. I've got 1 1/3 divided by 1/2. So I want to make this thing improper. 3 times 1 is 3 plus 1 is 4. It's going to be 4/3 divided by 1/2. Well, this is the same thing as what? 4/3 times 2 over 1. And now I just multiply these things. What is 4/3 times 2? 8 over 3. Is that thing reducible? Is it reducible? I could turn it back into a mixed number, but it is not reducible. 8/3 is, if I wanted to do it, what is that, 2 2/3? But I prefer it as 8/3. Well, I mean, just for my own aesthetic, it's prettier. Okay. Okay, do these 4 on your mark, set, go. 6, sorry, highlight. There's 6 of them, do them, go. These 6 questions, go. What do you mean, what else would you do with them? Do them, do the math with these 6 questions. Do them. No, everything, do everything. I'm not reviewing simplifying because I feel like you can all do that. Correct me if I'm wrong, but done, yes? Oh, okay. This is going to be in the video, so you don't necessarily have to take pictures of it. It's recording. I mean, if you want to take pictures, go nuts, but you don't have to. Okay, if you're done and I've already noticed that the next page is a bunch of questions, that's going to be your homework. There's not a lot there. You should be able to crank that out in class. I would love to move on to talking about fractions, decimals, and percents, just to, yes, front and back. Yeah, see, there's yeah, it flips over. Yeah, you do both of it, you do all that. We'll see where you guys are at in about 10 minutes. Oh, no, if you leave it as mixed? No, that's fine. Yeah, that's fine. So yeah, you could write, one question was brought up, even though I said it earlier, I was serious. I don't care about whether or not you leave things as mixed or improper, as long as it's in lowest terms. So these are the mixed number answers. If you want to leave them as mixed, you're welcome to do that too. Just because I find it aesthetically pleasing to leave them improper, it doesn't mean you have to. Yeah? So you put the negative in the denominator. It's not wrong, but it's not conventional. You'd either write it as negative 2 or 49, or you'd write it as negative right in the middle, 2 or 49. It's not wrong, but that's not a practice that I'd want to do because it's not going to be useful later on. Does that make sense?